Now, when you're looking at the brain's pretty important. In fact, have you ever heard of anxiety, depression, attention deficit disorder, impulse control, schizophrenia, any of these things? Well, all of these are a feature because the brain's divided up into little different areas. They call them lobes. Well, frontal lobe is where all this stuff is from. Now, what's interesting is that frontal lobe is programmable. But let's look how, because in crazy world, which is where the majority of us live, they think that these are different, that you need a medication for it, that it's a disease. Or is it really an adaptation? So now, when we look at the brain is only about a kilo. Let's say it was 2 pounds. It's 50% cholesterol, because cholesterol is the most important molecule of the body. In fact, cholesterol is the precursor to every hormone you make. Without cholesterol, you can't make steroids, you can't make sex hormones. Every cell in your body, except for red blood cells, have a double layer of cholesterol around it. It's the most important structure that you have, and that's 50% of the brain. Okay, and then it burns 90% of the body's oxygen. Wait a second. Every muscle in your body, you put it in a big pile. This brain burns more oxygen than all of that. It also burns 30% of the body's calories. This is why when your mom said, "You are what you eat," she was right. Okay, so now let's look at this. When we look at how this system works, the gut brain, they also call it the enteric brain. That's one part that's vital. Also, the position and motion of the vertebrae is vital. So when you look at how the structure actually is, you've got a curve in the neck, a curve in the mid-back, and a curve in the low back. And this is normal. Now, motion is vital for the brain function. But you already know that. Has anyone ever seen somebody with Parkinson's or autism or any kind of brain damage? Are they walking around like this? Or are they walking around like this? Because you need the position and motion of the vertebrae. This is why when I'm doing the adjustments, I'm working on the feet, working on the legs. I'm getting this communication back up to the brain. So when you have a normal position and motion of the vertebrae, you have normal stimulus to the brain. The problem is, let's say that you might have a loss of curve or a reverse curve in the neck. So instead of this, you have a reverse curve or loss of curve. Let's say that instead of a beautiful lumbar curve, you've had some kind of curve. Now, people aren't walking around like this. So where the back should curve out, it dips in. But don't wait. What if there's any kind of sideways deviation? Now, people in here, I've taken your x-ray. Is this familiar? It is. Now, the body's going to give symptoms. It's going to give symptoms like a headache. 97% of all headaches are coming from the neck. So now when you have loss of curve, reverse curve, or any deviation from normal, you're getting abnormal stimulus to the brain. Now, when you're looking at the brain, you've got this small brain on the back called the cerebellum. And literally, that kind of looks like a leaf there. When you slice open, I did human dissection anatomy for on and off for about 8 years. And when you take that cerebellum and slice it open, it looks exactly like a tree. And even the ancient Greek guys called it arbor vitae, or tree of life. It's so cool. I mean, the more you know about anatomy, the more you think, wow, we're really neat. Now, the cerebellum is where all of these sensors interface in. What that means is that on each of these vertebrae, there's 3 sets of sensors. The joints have mechanoreceptors, the little tiny muscles have muscle spindles, and even the ligaments have sensory components. So when you have an abnormal stimulation to that cerebellum actually controls the frontal lobe. So does that mean that you can see brain damage just the way people walk? Remember, human beings walk like this. Brain damaged kids are walking like this, toe walking. You look at standard adults that are walking like this because they don't have that balance. They don't have the proprioception. And if anybody has poor balance, if they have dizziness, okay, dizziness, what is that? Remember, that brain, what does it do? Burns 90% of the body's oxygen. And what is balance issues? What's dizziness? What's passing out? Why is that important for the brain? So you got the brain up here. If that doesn't get enough oxygen, the body kicks the legs out so it gets level with the ground to keep the brain alive. Dizziness and balance issues are a major clue to poor stimulation of the brain or poor oxygen, and the body is going to stand for that. If that brain dies, you die. Okay? It's just like if you put your body on an iceberg, dressed in, extremely attractive clothes. No, these are attractive, Doc. Don't give me your fashion opinion. No, but I mean, if you're dressed like this, you're going to get so cold that the body will shut off the blood supply to the arms where it's frostbite to keep your core alive. Same thing with the structure. It's going to shut down a lot of the different structures here and processes keep the brain alive. This is why if you have an abnormal stimulation, normal body posture, then the body is going to generate movement. So what does this movement look like? I know Parkinson's, okay? But what's interesting is the movement is the brain's defense mechanism to get stimulation up. Is this why every patient that we adjust, what do we do after we adjust you? We get you in there to do symmetrical movements. Because every adjustment we do is for the brain. Does that mean back pain, neck pain and stuff? I don't care about that. But the pain is a fire alarm. So does that mean that high blood pressure isn't a disease either? It's really an alarm telling you that you're under stress? So let's look at this. We have the gut-brain. Now, the stomach area is where neurotransmitters are produced. It's massive sensory input. Now, there's one nerve that exits the base of the brain here, and it controls the movement, it controls acid secretion, it controls liver function, controls every part of digestion. It's called the vagus nerve. No, it's not Vegas, baby. I mean the nerve. The interesting part is all of those functions of the vagus nerve are only 10%. 90% of the vagus nerve is sensory input to the brain. So wait a second. So the brain has two sensory inputs from the position and motion of the vertebrae and from the gut. Now, why is that so important? Because we need that sensory input because this digestive tract, where the stomach is, the throat, everything else, that's our connection to the outside world. So when you smell broccoli, your stomach produces a certain acid to break it down. When you smell lamb, different acid. Chicken, different acid. So this smell goes into the brain tells the digestive tract, because that digestion is where the body is going to break down the nutrients to proteins, fats, carbohydrates so you can live. So does that mean if you have a toxic and deficient diet, you're going to have abnormal brain function? And this is why 100% of the people with brain damage, autism, Alzheimer's, dementia, multiple sclerosis, Parkinson's, that we have to change their gut. We have to get it. And you already heard of this, that people are doing fecal transplants. They're changing the intestinal tract flora, and you're seeing people with dementia go. Now, why is that? Because this is where neurotransmitters are produced. Now, the body only has two switches, and it's called an automatic or autonomic nervous system. And everybody knows this. One switch is protection, and that's the fight or flight. The other one is regeneration. Now I'm going to demonstrate on my patient here by stepping on his toe. Say, ow. Thanks for playing. Okay, but by crushing his toe, what happened to the heart rate? It went up. Okay, what happened to the cholesterol levels, or the glucose levels? Instantly, under that painful stimulus, not only does he want to punch me, you can punch me later, okay, But he's got to get away from danger. So the liver's breaking glycogen down to glucose. So by crushing his toe, his heart rate and blood sugar went up. Now, you heard of cholesterol, right? Good and bad cholesterol, which is foolish because there's only cholesterol. There's different types of carriers. There's low-density carriers. There's high-density carriers. But why would his LDL cholesterol go up after I crush his toe? Because low density is not bad cholesterol. It's actually used for tissue repair and hormone production. HDL is not good cholesterol. It takes the cholesterol from the site of the repair back to the liver for storage. So what I just did is I caused physical stress on him. I know, you're going to key my car and yeah. Okay, when we're on the golf course, you're going to beat me with a club. So physical, chemical, and emotional stress all activate the protection method, that sympathetic nervous system. So does that mean if someone is physically stressed, they're in a chronic state of protection? And this means poor digestion, everything else. What if they're chemically assaulted with poor sleep and poor diet? Okay, and emotional stress is based on perception. This is why 100% of our patients, we look at the physical, chemical, and emotional stress to get them out of the protection into regeneration. Does that make sense? Yes or yes? I know, I'm only giving you one choice, okay? Because anything else is insane. So now, can you imagine a culture? Because I'm still standing on your foot. Your blood pressure is elevated, your blood sugar is elevated, and your cholesterol is elevated. So when we're looking at depression, anxiety, impulse control, attention deficit disorder, all of these things, they're all features of the frontal lobe. Can you see when you have abnormal stimulation, you've got chemical assault from poor sleep, poor diet, okay, and then you're feeding your mind with this electronic stuff saying, oh my gosh, the war is bad, this is bad, that is going to cause this frontal lobe to respond correctly, putting you in a stress state. Does that make sense? Yes or yes? Yeah. And so anyone reducing their cholesterol levels, it doesn't clog arteries, it's actually vital for everything. Is blood pressure the number that the doctor says you should have? Is it based in science? But let's look at that. Okay, so now I have a 200-kilo patient, 200 kilos. He runs a cigar store. And I have a 12-year-old gymnast. Now, should they have the same blood pressure? No, of course not. I mean, but that's common sense. For every 1 mile of blood vessels, okay, 1 pound of fat, there's 20 miles of blood vessels. So this person's 50 pounds overweight, that's 50 miles the heart's got to push. So for him to survive, does it make sense that his blood pressure should be higher than the other, right? Okay, I'm only hitting common sense here. Okay, now, did you check your dog's blood pressure this morning, or your cat's blood pressure, or your fish's blood pressure? No. Why would you do that? They regulate themselves. So you have been taught a lie that blood pressure is an issue. Now, type 2 diabetes, is that a disease or a poisoning? I'll tell you right now, you change your diet, within a month, you no longer have diabetes. Blood pressure is normalized in about a week. Cholesterol, we have to change your brain to make you understand what cholesterol is. So none of these are diseases, but they are medicated form. Now, this is why when we're looking at the brain, position and motion of the vertebrae are vital. This is why we give exercises to restore the curve. When you're sitting, we give exercises to restore the lumbar curve. When you're walking, we show people how to walk symmetrically so their arms are coming up to the same height. When you're working out at a gym, you're no longer working like this. You're working one up, one down, so they cross in the air. So every activity that you do is designed to change. If you've ever seen the incredibly sexy shoes that I wear, don't you smile. Okay, your wife is way better at fashion than I am, so is mine. I wear these shoes not because they're incredibly good looking, but they give full range of motion of the feet that gives more stimulus to the brain. What do we do with our kid patients who have brain damage? Okay, we get off the shoes, they take them off so they can walk barefoot so they get more stimulus. Well, how do we get Alzheimer's patients better? We tell them to walk barefoot in the grass with symmetrical movement. Okay, this brain is in a constant state of regeneration. And that's the cool part. It's alive. You just got to restore the position and motion of the vertebrae. Now, when you have a loss of curve, the cerebral spinal fluid, which is how the brain, because the brain makes its own food. It doesn't get it from the stomach, okay? It gets it by producing cerebral spinal fluid produced at the choroid plexus in the middle of the brain, and that fluid flows down around the brain and down through the spinal cord. Now, if that fluid is locked or blocked because of a loss of curve, I'll touch the top of the head where the bones join together, and I'll feel heat and tenderness. Raise your hand if I've checked your head and we saw it tender a few days ago. It's better already, isn't it? Why? All we're doing is taking a loss of curve to a more normal curve, and then the fluid can drain. The body is so smart. So this is why we check the structure. This is why we talk about changing the sleep and diet. And this is why we talk about reprogramming the emotional component, because this is not a disease. This is the body adapting to frontal lobe function. And the frontal lobe is adapting to poor gut function, chronic state of stress, or physical. So it's really physical, chemical, and emotional stress that alter that brain function. Does that make sense? Okay, any questions? Yes, you know I'm looking at you because you always have good questions.
People with high
Okay, number one thing. So here's the question. With somebody with a high A1C, what can we do to lower the A1C? Okay, so a high A1C. Now, is that, and it's supposed to be a precursor to diabetes. Okay, what about a genetic marker, like an MTHFR gene? Okay, so what's the difference between genetic and genetic expression? Everything. So you can have every gene, you can have an HLA-B27, which is common in a lot of autoimmune conditions, and never have it expressed. So 5 people, all with a high A1C. You've never met them, but I want you to tell me what they have. Good sleep or bad sleep? Okay, you tell me. You've never met them. Good diet or poor diet? Wait, so you're telling me that these people don't have a high A1C? That the high A1C is only a red flash and light to tell you there's a problem? Mild, if that fire alarm goes off, I want you to take it out. Of course, Jen is going to say that there's a fire. High A1C is not. What you got to look at, and this goes along with blood pressure, cholesterol, blood sugar, any of that ridiculous stuff, is look at the physical, chemical, and emotional stress, because that is the body adapting correctly. If you see parasites in the blood, that's because the parasites have food, because you're not producing healthy cells. So how do you get healthy brain function? How do you get healthy cells? Eat right, sleep right, think right, and move right. I mean, it can't be that simple, but it really is. Now, any questions about this? And this is good. So what type of food will lower an A1C? Is an A1C just a stress marker? Absolutely. And what's cool is his diet should be the same as the 10,000 generations that preceded him. So what did your great-great-grandmother eat? I know you know her. She was whacked. She only ate organic. She only ate seasonal. She only ate free range. If they were preserved, it was fermented. And this is how your body is. And what should you sleep? You should sleep deep at night. You shouldn't be watching TV before bed. Okay, so you live within the parameters of your system. If you had a sick caribou, what are you going to give that caribou so it can get healthy? You're going to say, eat what the other caribou are eating, stop licking the oil derrick. You know, it's basic. It's the A1C is not a problem, and you don't want to lower it. You want to be a detective to identify the physical, chemical, or emotional stressors. You got to identify abnormal stimulus to the brain or normal stimulus to the brain. So could somebody that's chronically slouching, that has chronic poor movement, because movement charges up the brain, could they be in a sedentary lifestyle and not exercise, and they sleep more than 9 hours a day? Will that put me in stress? Yeah, will that raise A1C? So what 3 things will raise your A1C? Physical, chemical, and emotional. You're right. So diet is only a third of that, maybe. Could we all be watching a scary movie and have the A1C go up? Yeah, it could. I know if under any kind of fear, blood sugar is going to be elevated. In any kind of fear, the blood becomes thicker. Did that answer it? Yeah, so the diet should be like your great-grandparents. What I want to get away from, and I'm not, because most healthcare people they still have that allopathic mind. What kind of diet should you use to lower A1C? Well, you eat more protein, eat less refined carbs. That didn't help him, okay, because that's an allopathetic, okay, answer. It makes him think that A1C is actually a problem instead of the intelligence of the body adapting. Okay, we're in a fear-based ignorant system that measures your cholesterol, it measures your blood, your A1C, all these different blood markers. Okay, and they're not telling you that it's really the body adapting correctly based on the stress level. Does that make sense? If your blood cells are sticking together, should you take bentane hydrochloric acid to open up the cells? Or should you fix the sleep patterns? You know, I'm a big cause person. Any other questions? Kapung krap. Thank you very much.